Right now, something is cutting through the air above the Nevada desert, something that swallowed more than $1 trillion to build. Something the United States government assembled entirely behind closed doors, shielded from public scrutiny, stripped of congressional oversight, and buried so deep inside classified budgets that most Americans never had a chance to question it. By any measure, it is the most expensive weapon the United States has ever produced. And until very recently, the vast majority of Americans had never once heard its name. This is the story of the F-47. And once you truly grasp what this aircraft represents and what it reveals about the direction the world is heading, you will never look up at the sky quite the same way again. Why build a ghost plane at all? To make sense of why the Pentagon funneled $1 trillion into an aircraft that almost nobody was supposed to know existed, you first have to understand the quiet crisis that had been spreading through the upper levels of American defense leadership like a slow-moving fire. For roughly 2 decades, the U.S. Air Force stood in front of the American public and sold the F-35 Lightning II as the pinnacle of aviation achievement. The definitive fighter, the last word in air power for a generation. They invested $1.7 trillion making that argument, and for a long time, the argument held. Then, somewhere inside the closed rooms of the Pentagon, someone sat down with the data, really sat down with it, without the spin and the institutional pride, and came to a conclusion that nobody in a position of authority actually wanted to deliver. The F-35 and its older sibling, the F-22 Raptor, were quietly becoming relics. The F-22 remains a fearsome machine in the right circumstances. In a close-range dogfight, there is almost nothing that can touch it. Mach 2.25 top speed, thrust vectoring, and a combination of agility and power that very few aircraft on Earth can approach. But warfare across the Pacific Ocean is not a close-range dogfight. It is a chess match played across enormous distances. And with a combat radius of only 460 miles, the F-22 would burn through its fuel long before it ever reached the Taiwan Strait. In that particular conflict, it would not be a weapon. It would be a liability with a very expensive price tag. The F-35 carries a different kind of problem. It was engineered to be a flying supercomputer, not particularly fast by fighter standards, with a top speed hovering around Mach 1.6, but wrapped in layers of radar-absorbing stealth material designed to make it effectively invisible to enemy sensors. Every design decision made on that aircraft flows from a single foundational assumption: that stealth works, that radar-absorbing coatings will keep it hidden, that the enemy's detection systems will never catch up. The terrifying question no one wanted to ask out loud was simple: what happens the day that assumption turns out to be wrong? China didn't copy us, it built the counter to us. This is the part that keeps American defense planners staring at the ceiling at 2 in the morning. China did not spend the last 2 decades trying to replicate American military technology. That would have taken too long and produced results that were always one step behind. Instead, Chinese defense engineers did something far more strategically sophisticated. They studied American aircraft with painstaking care. They mapped out the specific weaknesses of each platform, and then they built their own weapons from the ground up to target those exact vulnerabilities with surgical precision. By late 2025, China is estimated to have more than 300 J-20 Mighty Dragon stealth fighters in active operational service. The J-20 has a combat radius exceeding 1,000 miles, more than double what the F-22 can achieve. In practical terms, that means Chinese aircraft can reach and destroy American aerial refueling tankers and airborne radar platforms from distances where U.S. fighters literally cannot get close enough to respond. In a shooting war over the Pacific, Chinese pilots could fire first, fire from further away, and American pilots might go down before ever getting a weapons lock. China's PL-15 air-to-air missile carries an estimated range somewhere between 124 and 186 miles, a figure that may already surpass the reach of America's most capable air-to-air missile, the AIM-120D AMRAAM. The mathematical implications of that gap are not subtle, but perhaps the single development that most fundamentally shook the Pentagon's faith in the F-35 is something harder to categorize and harder to counter. China has claimed to have developed what it calls quantum radar, a detection system built around single-photon technology that does not work the way conventional radar does. Rather than bouncing electromagnetic waves off a target and waiting for the return signal, this system reportedly detects the subtle quantum-level disturbance that a stealth aircraft creates as it moves through space. If that technology functions as advertised, then every dollar ever spent painting the F-35 with radar-absorbing coating becomes worthless, not reduced in effectiveness, worthless, overnight. Facing that possibility, the conclusion that slowly hardened inside the Pentagon was painful for the people who had spent careers defending the existing approach. The F-35 had been oversold, the F-22 was range-limited, and the solution was not an upgrade, not a patch, not a next version of the same idea. It required starting over from scratch, a total reimagining of what an American combat aircraft needs to be in the era of great power competition. That reimagining became the F-47, the engine that changes everything. If the F-35 is best understood as a flying supercomputer, then the F-47 is better understood as a flying power plant. The core of this aircraft, the component that caused its development costs to spiral into numbers that seem almost fictional, is not its stealth configuration or its weapons systems. It is the engine. A piece of propulsion engineering so fundamentally different from anything that came before it, and so extraordinarily difficult to manufacture, that prototype development contracts alone consumed more than $7 billion. For the better part of 7 decades, building a jet engine has been an exercise in accepting trade-offs. You could optimize for fuel efficiency and range, or you could optimize for raw thrust and outright speed. Doing one well meant sacrificing the other. Every jet aircraft ever built, from the earliest Cold War fighters to the most modern combat planes, lived somewhere inside that compromise. The physics seemed immovable. The F-47's adaptive cycle engine tears that trade-off apart. The engine, known as the XA-103 and developed by Pratt & Whitney in competition with GE Aerospace's rival XA-1000 design, uses what engineers call a 3-stream architecture. Rather than operating as a fixed system, it physically restructures its own airflow during flight depending on what the aircraft needs in that moment. During cruise flight, it opens a third pathway for air that dramatically improves fuel economy and dissipates heat, delivering roughly 30% greater range than any current American fighter. When the aircraft transitions into a combat situation, that third stream closes in a fraction of a second, and the engine becomes an entirely different machine, a raw thrust generator capable of speeds that would leave any currently operational fighter far behind. That extended range has enormous strategic consequences. An F-47 operating from Guam can reach the Taiwan Strait and return to base without ever needing to connect with an aerial refueling tanker, which means it does not need to expose the tanker to enemy fire, removing one of the most dangerous vulnerabilities in America's current Pacific War plan. But the range improvement, significant as it is almost a secondary benefit. What the engine's power generation capability enables is the real story. The F-47's adaptive engines produce nearly a megawatt of electrical power while airborne, approximately 10 times what an F-35 generates in flight. And that enormous electrical surplus was not engineered by accident. It exists to power one specific system. The F-47 carries a laser weapon. The weapon, they said, was cancelled. In 2024, the Air Force publicly announced it was shutting down a program called Project Shield, an initiative to mount a directed energy laser weapon on a fighter aircraft using an external pod system. Defense journalists covered the cancellation, noted the cost overruns and technical challenges, and moved on. As far as the public record was concerned, the Air Force had tried to put a laser on a jet, failed, and given up. That story was not the complete picture. What the Air Force abandoned was not the laser. What they abandoned was the pod. Mounting the weapon externally protruded from the aircraft's surface and shattered its radar cross-section, turning an invisible aircraft into something much easier to detect. The engineers had not hit a dead end. They had identified the actual problem. You cannot bolt a laser onto a stealth aircraft and expect it to remain stealthy. You have to build the aircraft around the laser from the beginning. That is precisely what they did. The F-47's laser system, referred to internally as TALS, the Tactical Airborne Laser Weapons System, is engineered to solve a problem that no existing weapon in the American arsenal addresses effectively. When an incoming Chinese PL-15 missile closes at 4 times the speed of sound, the TALS system does not attempt to physically intercept it. It does not try to knock it out of the sky. Instead, it targets the missile's guidance sensor and burns it out in a millisecond. The missile continues on its trajectory, still moving at Mach 4, but it has been rendered functionally blind. A weapon worth millions of dollars becomes a random piece of fast-moving metal with nowhere particular to go. What this creates, in practical terms, is a magazine that never empties. The laser fires as long as the engines are running. There is no reload. There is no moment of exposure while a pilot tries to cycle through remaining munitions. There is no scenario where the aircraft has expended its last defensive shot and is suddenly naked in a threat environment. For as long as the aircraft is airborne and the engines are turning, it can defend itself. China has publicly claimed to be pursuing the same technology for the J-20 platform, reportedly powered by their new WS-15 engine series. Whether that represents a genuine operational breakthrough or an elaborate strategic communications effort designed to pressure American defense budgets into accelerating spending is genuinely unclear from the outside. With Chinese military announcements, the gap between a functioning weapons system and a carefully crafted public relations campaign has always been difficult to measure with confidence. The pilot is the most expensive problem. There is one more dimension of modern air warfare that the Pentagon has been rethinking quietly for years, and it may be the most philosophically uncomfortable of all the changes the F-47 represents. The problem is the human being sitting in the cockpit. The human body loses consciousness at approximately 9 times the force of gravity. An autonomous aircraft with no person aboard can execute maneuvers at 20 gs turns and pulls and evasive actions that would instantly kill any pilot in any aircraft ever built. The physics of aerial combat have always operated under a hard ceiling imposed by human biology. Whoever figures out how to remove that ceiling first gains a tactical advantage that cannot be countered by a pilot-dependent aircraft. The financial dimension compounds the problem. Producing a single elite combat pilot costs upwards of $10 million and requires years of sustained training investment. If that pilot is killed in action, the loss is not just human, it is the irretrievable destruction of both the financial investment and the years of accumulated experience and judgment that existed only inside that person. The F-47 is engineered to be optionally manned. The cockpit exists, a pilot can fly it, but the pilot is not required, and the aircraft is designed to operate in concert with a fleet of more than 1,000 autonomous collaborative combat aircraft drones that cost approximately $27 million each, roughly one-third the price of a single F-35 that can be directed into high-threat environments while the manned aircraft remains further back, outside the most dangerous zones. The strategic logic this creates is cold and precise. The F-47 pilot functions less like a traditional fighter pilot and more like a quarterback calling plays from a protected position. The drones absorb the exposure. The drones take the hits. And when a drone is destroyed, the cost in both money and human life is a fraction of what it would cost to lose a crewed aircraft and its pilot. China has not been waiting for the ethical debates to conclude. The J-20 has already been developed in a 2-seat variant where the second crew member is not a co-pilot in any traditional sense. That person is a drone commander. China has moved the loyal wingman concept from a think tank paper into operational practice while the United States has still been arguing about whether it should. The secret that was already out. Here is where the story takes a turn that may genuinely catch you off guard. The F-47 is not a future program. It is not a proposal being developed for some conflict a decade away. It is not a rendering on a briefing slide at a defense contractor's facility. It has already been flying. In September 2020, Dr. Will Roper, who at that time served as the Air Force's senior acquisition official, made a statement to Defense News that the Pentagon has spent considerable energy trying to contextualize and pull back from ever since. He confirmed, on the record, that the Air Force had already built and flown a full-scale 6th-generation flight demonstrator in actual operational conditions. Not a scaled-down test model, not a simulation. A full-scale aircraft that had already broken performance records in real-world flight testing. That statement was made more than 5 years ago. If the aircraft was already breaking records in 2020, then the concept imagery that appears in news coverage today is not showing you what the F-47 is. It is showing you what it looked like years earlier, before additional development cycles and refinements that occurred entirely beyond public view and without public knowledge. Satellite analysis of the Groom Lake facility, the installation the public knows as Area 51, has identified significant new hangar construction on the southern portion of the base. The dimensions of these new structures are too large to accommodate an F-22 but smaller than what would be needed for the B-21 Raider strategic bomber. The measurements align, with uncomfortable precision, with what analysts believe the F-47's physical profile to be. The Air Force may not simply be testing this aircraft in the Nevada desert. There may already be an operational fleet parked in those hangars, hidden from satellite angles that are not quite the right angle to see inside. So what does this all mean? $1 trillion spent in classified programs, on an aircraft that was already airborne while the public was still being told it lived somewhere in the future. The F-47 is not simply a more advanced fighter jet. It is the physical embodiment of a fundamental transformation in how the United States intends to conduct warfare: autonomous combat systems, directed energy weapons capable of defeating guided missiles, artificial intelligence woven into combat decision-making, and aircraft designed from the start with the option of carrying no human pilot at all. These are not laboratory experiments being prepared for some distant hypothetical conflict. They are capabilities being actively tested, continuously refined, and apparently already deployed in some operational form, right now, in the present. The question the Pentagon most wants to avoid is not whether the F-47 is real. The weight of available evidence suggests, with considerable confidence, that it is. The question that a functioning democracy is supposed to be able to ask and apparently could not is whether a government should be permitted to spend $1 trillion in total secrecy on a weapons system that no electorate voted on, that no legislative committee fully reviewed, and that no public debate ever had the opportunity to shape or challenge. The ghost is already airborne. What it does next is something that none of us, at any point, were asked about.